Hey, so we've come to the end of the series on Lewis structures of things that violate the octet rule with 5. We'll start 6 soon, but I saved, I guess, the best for last. This is an interesting structure, and it's something that brings in a lot of different skills. So we're going to work today with the I3 negative 1, the TriIodide ion. Okay, so you get three iodines. One of them has a negative charge, and so it's just TriIodide. So when we do a Lewis structure, we have iodine, and you have 3 of them, and each one has 7 valence electrons. So 3 times 7 is 21. But then here's why I like this. You don't want to forget that negative charge, so that adds on. And so it is 22 total electrons, which is, it seems strange because we had more last time, but you got to think that here we only have 3 things to put on, okay? So pick an iodine, any iodine, and make that your central, okay? It doesn't matter which one because they're all iodine. But do remember that iodine can violate the octet rule. It's big enough. The halogen that cannot violate the octet rule is fluorine. Now, so I'm just going to stick my other 2 iodines on here. And so that takes 4, so now I'm down to 18. Okay, and then I'm going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And so that takes care of 12, and so that leaves me 6. All right, so I've got this iodine taken care of and this iodine taken care of. This iodine's got access to 4, but I've got 6 electrons left over. And I can't just go 2, 4, and say bye, because that would leave 2 electrons on the table. And when we add up our electrons correctly, we have to use all the electrons. So what I'm going to do is that central atom gets all those pairs of electrons, okay? And so there is this guy right here is in the middle. We're gonna give the extras to him, and then we've got 2 that are, you know, pretty good. Well, 2 that are taken care of, and then 1 here that may be a little problematic, but we'll do some formal charges. Now, when I do the structure, the actual physical structure here, I'll put that in front of my t-shirt so you can see it. So you've got unshared pair, unshared pair, unshared pair. And then they the unshared pairs arrange around the belt of the central atom, and then up and down or side to side. It really doesn't matter how you draw it, whether it's oriented that way or that way. But what you need to know is that since those unshared pairs, you know, it's not, they don't have mass, and they don't really, it's not something you can see. They enact field, but they're very small because they're electrons. What we're seeing, I'm not seeing anything because they're atoms, but you know what I mean. But what we're seeing are the 2 other atoms. So you got an iodine here, and then an iodine here, and an iodine here. And those all, they just look like they're in a line, but they're being pushed into that line because you have this unshared pair, unshared pair, unshared pair there. Okay? So how we would draw that is you just draw your iodines in a line, and you have one set that's on the plane, and you got one coming out and one coming back. Okay? So there's my set that's going back, there's my set that's coming out, there's my set that's on the plane. And so essentially I've drawn drawn that. And you can see my finger really good. That's kind of what you can see there. Okay, nope, not getting any better. Heck with it. You saw it both times. Okay, now let's look at the formal charge. So we've got an A, a B, and a C. And so A and C are going to be the same. A and C are the same because they're bonded the exact same way. And they're also bonded typically for a halogen. So 7 minus 6 plus 1/2 of 2 is 1, so that's 0. And then you look at this. Now I'm going to make a Kreskin prediction here. Look up Kreskin if you don't know who that is. And I'm going to say that this other iodine is going to be -1. So I've got 2, 4, 6. Okay, plus 1/2 of 4, which is 2. So I've got 7 minus 8 equals -1. Oh, wow, look at that. That's really cool. And so that validates the structure that I've drawn in that right here. See that? We have a -1 charge, and so our formal charges have to add up to -1. So I've got a formal charge of 0 here, 0 here, and -1. And I'll do a video next about the blooper reel, about another way we could try to structure that and see if that works out better or worse. All right?